All right, so we're going to be doing some factoring. So all of the things that you learned to do in Algebra 1 with factoring, we're going to be doing those things today, and we're going to get into quadratics and higher degree polynomials in the next couple of weeks here. And so a lot of the things, everything we've done so far, with the exception of the RREF, has been an Algebra 1 thing. This is still Algebra 1 stuff, so we're still working on those same things. We're trying to add a few things as we go. We'll add a few things with quadratics that you didn't do in Algebra 1. We'll add a few concepts with that, and then we'll get into higher degree polynomials right after that. So let's talk about the rules of factoring. Folks that had me for Algebra 1 have heard this before, but I call it the rules of factoring because if you follow these rules, the same rules occur not only for quadratics, which is where we're at right now, but when we get into higher degree polynomials like x to the fourth power, x to the fifth power, stuff like that, same rules. Nothing's different about it. So the first rule of factoring is make sure that your polynomial is in descending order. Descending order means by the exponents on the variable. So with quadratics, your x squared comes first, then the plain x, and then the number. So descending order, highest power to lowest. Highest power to the lowest power. That's what that means. Okay. And then number two, the first type of factoring that we learned how to do was GCF, which stands for greatest common factor. Remember, that's the largest number or variable that you that will go into everything in the problem. So GCF is what we're going to look for first, and then if there's a GCF, we're going to pull that out outside the parentheses and then apply the next thing, which I call it just counting terms. Based on the number of terms that you have in the problem, tells you what method of factoring that you can do. If there are four terms, does anybody remember the method that we use when there are four terms? Starts with a G. Grouping, yeah. We'll see that some today. And then if there are three terms, I call it this X method. If you had me or Coach Mack, or I think Miss Price used the same naming, the X method for factoring. If you haven't seen that before, it's just a different way of organizing your thoughts on a trinomial, which is three terms. It's really easy to pick up, and I think it helps just keep you organized. And then two terms. Two terms, the only thing that we've learned up to this point is called difference of squares. We'll review all of these things and get you on track with factoring quadratics or just polynomials in general today. So make sure it's in descending order. Check box if it already is. Look for a greatest common factor. There's not always a greatest common factor, but always look for it because it makes things easier if there is. And then we're going to count the terms that are left, and based on the number of terms that we have, we're going to learn some methods to do or review the methods of factoring those things. So let's just start. The instructions are just going to be factor. Tomorrow we'll add the solve part to it. 12K minus 18. And it doesn't matter what letter we use. I'm just using K because we'll use X plenty today. So, now, descending order, what's the exponent on this K that's right here? 1. If there's nothing written there, it's an understood 1. And then the 18 doesn't have a variable, so it's in the right order. The next thing to look for is a greatest common factor of all the terms. So what do both of those have in common? 6 goes into 12, 6 goes into 18. 9 goes into 18, but it doesn't go into 12. So 6 is the largest, thus it's the greatest common factor. So we're going to pull out the GCF of a 6, and then what's left in the parentheses? Good job. Then we look at what's left in the parentheses and say, can I do anything else to that? No, I can't on this one. That's the factored form for that one. Good job. Let's go a little bit bigger. 40x to the 8th plus 64x to the 4th. Let's go bigger. Go big or go home, I say. That's a pretty big one. Is it in the right order? Yeah, x to the 8th is first, and then x to the 4th. So that's biggest and then smallest. That's the right order. So the next thing to look for is a GCF. 40 x to the 8th and 64 x to the 4th. 8 goes into 40 and 8 goes into 64. True. And that's pretty big. Is there anything bigger that goes into 40 that might go into 64? Okay, x to the 4th power is going to be shared between them. So 8 is the number part. So we're going to pull the 8 out. And then 4 x's is what they have in common. The first one has 8 x's to begin with. The second one has 4. So the only way they're sharing 4 of them. So the common part is x to the 4th. And then what's that leave in parentheses? This is the harder part. What times 8x to the 4th gets me 4? Yeah, 5 for the 40, x to the 4th for the x to the 8th, plus, do I need any x's? No. Good job. There's factored form for that one. Good job. So there's a higher degree polynomial. You're already doing it. Good job. Let's go. 3. 14 x to the 6th power minus 35 x to the 3rd power minus 7x squared. So just putting some stuff out there, and we're going to see if we can find it there. All right. Is it in the right order? 6, 3, 2 on the exponents. That's the right order. And then 14, 35, and 7. Do they have a greatest common factor? 7. Good job. Yeah, x squared. Both of usually on the variables, you look for the smallest group, and that's the one that's going to be the GCF. If they all have that letter, look for the smallest set there. So x squared is the smallest set. So what's that leave in the parentheses for the rest of it? 2x to the 4th power to the 1st. That's right, because it had 3 to begin with. We took 2 of them out here, so there's 1 left. Then the last piece, minus 1, I heard somebody say, and that's the right thing. Got to have all 3 terms represented left in that parentheses there. We're going to stop there. There's nothing else that you could do to that parenthesis on this one, because this is x to the 4th and plain x, and that you can't factor that. It would have to be x squared and plain and an x here to be able to do that. We're going to get there in just a second. 3x to the 4th, and then minus 5x plus 8x squared. What we got? Say it again. They're not in order. Oh, we got to fix that. So how do I rearrange it? Okay, so be a plus 8x squared in the middle, and then the minus 5x goes after that. right? Good job. Let's change the order, get it in the descending order. And then what? Greatest common factor is what? X. Good job. That gets us 3x cubed plus 8x minus 5. And again, that terms there, we got x cubed and then plain x. It needs to be x squared and plain x if we're going to be able to do anything with it. So nothing we can do with that on that one. So done. All right. Descending order GCF. So the first 4 examples here really just get you looking for a GCF. You won't always have a GCF. Sometimes you might get a problem maybe like this. X squared plus 14x plus 45. Something like that. It's in the right order. Got x squared, plain x, and then a plain number, so it's in the right order. But there's nothing in common between all 3 terms, so no GCF on this one. So that gets us to the third step in the rules of factoring, which was count the terms. How many terms do we have here? 3, and this is where I say I call it the X method. You may have learned it a different way, but it's the same idea. The way I do the X method is I draw myself a big X over there beside there, and quadratics are written in that way, and A is always in front of x squared, B is always in front of x, and C is always the number on the end. That's how quadratic expressions are always written. The number up top, on the top of the x, is A times C, always. So what's A for our problem? What's in front of x squared? 1. And C is positive 45. So 1 times positive 45 is a 45. So that's what goes up there. And then the number in the bottom part of the x is always B. So what's B in this problem? Positive 14. So here's what we need to find with this. We need 2 numbers that multiply to be 45 and add to be 14. That's what the X setup is about. We want to multiply to be the top number. So multiply and add to be 14. That's what we want 2 numbers to fill in the sides with. So what 2 numbers? So this is where knowing your multiplication tables is very important. If you don't know them, go to the dollar store and get some flashcards and look at them every day, and you'll know them in a week or so. It's not like elementary school where you had to work hard to learn those. You guys can memorize stuff pretty fast. So if you don't know your multiplication tables, either get the flashcard out or go to the dollar store and get a $1 set of flashcards for up to the 12s. What multiplies to be 45 and adds to be 14? 9 times 5 is 45, and 9 plus 5 is 14. So we found the 2 correct numbers there. And if you remember in Algebra 1, because 1 is in front of x squared, we can do what? Well, not equals, because we're not solving. We're just factoring. So it would be x plus 5 and x plus 9, because they're both positive. Now, if that number is not a 1 in front of that, you've got to go through the grouping step, in which you replace the 14 with the 5 and the 9, and then you group first 2 together. GCF is x. Second 2 together, GCF is 5. And then the factors, you got a matching factor, that's the x plus 9, and then the stuff in front is the x plus 5. So, but if there's a 1 in front, you can go straight to those factors here. If there's anything in front of x squared, you can't do that, though. You got to do the grouping stuff, okay? Let's do another one. Let's say we had 18x squared minus 24x plus 8. It's in the right order? Yes. So next thing we look for. Greatest common factor, which is 4 goes into 18. No. 2 goes into 18 though, and 2 goes into 24 and 8. So I'm gonna pull out a 2, be 9x squared minus 12x plus 4. And then, because I have x squared and plain x right here, that tells me, hey, I could probably do a little something, or at least I need to try to do the x method for factoring because it's got 3 terms. So I'm going to try to do that x. What goes in the top of the x? C. A is 9, C is 4, so that's going to be 36, right? And then what goes in the bottom? Negative 12, the B. We need to multiply to be positive 36 and add to be negative 12. Good job. Negative 6, negative 6. Now, I can't take the shortcut on this one because there's something in front of x squared. So I've got to put it in with the grouping step. So I'm going to bring my 2 down. I got 9x squared minus 6x minus 6x plus 4. And I'm going to group the first 2 together and get their GCF. And then I'm going to look at the last 2 together. So what's the GCF of this first pair? 3x. And that leaves 3x minus 2. And then the GCF of the second pair, this negative 6x plus 4. 2, but to make it match, I've got to pull out the same sign as right here. So I've got to pull out a negative 2. I remember doing that maybe. And that'll change it to 3x minus 2. So that those parentheses right there, these parentheses, when you do the grouping stuff, they have to match. If they don't match, something's going wrong. It's not working, okay? So those 2 match. So my factoring, I still got the 2 that's out in front. I hadn't changed that at all. It's still there. So I got the 2, and then I got the matching factor, 3x minus 2. And then I got the stuff in front. And it happens to be 3x minus 2 as well. So that's one way to write the answer. What would be a different way to write that answer? Since there's 3x minus 2 twice, what could I do here and make that say the same thing? Square it. Those mean the same thing. So this is how I'm normally going to write it because I know I'm going to do something different with it later. But here, that may be, if it's a multiple choice type situation, that might be what they put as the answer for the factored form. They mean the same thing, though. So keep that in mind. All right. Let's say we had 9x squared minus 25. Change it up a little bit here. Just trying to mix in everything that we do. Should have seen before, whether we're great at it or not, that's beside the point. Just the idea of things we've seen before. So, is that in the right order? Is there a GCF? No, 9 and 25 don't have anything in common. And there's no letters in common between the 2. And then we go to counting terms. How many terms does this thing have? 2. So that means it must be either a difference of squares or nothing. For everything we know right now, difference of squares is the only thing we can do with 2 terms. So difference of squares means that you can rewrite it as something squared minus something squared. Difference in math, remember, means subtraction, right? So that's why I'm just trying to rewrite it like this. If I can, then it'll factor real easy. So can I rewrite 9x squared as something squared? What squared gets me 9? 3, and what squared gets me x squared x? So there's a 3x that goes in that parentheses. Good job. And then what squared gets me 25? 5. Because I can rewrite it that way, that means it factors as a difference of squares. The two factors will have 3x in the front, 5 in the back. One's a plus, one's a minus. And since this is Algebra 2, at some point, I hope that you get to where you don't have to write this step out, or you may not have to now. You may just think that. So our brain needs to be able to think this way when it comes to that. We'll learn some other things when we get to higher degree polynomials very soon. There are other options when there are two terms that we need to memorize some patterns and things on. So make sure that you're locking that in to your brain there. Let's try this one. 16x squared minus 49. Well, is there a GCF? No. It's two terms with a minus sign in the middle, so I'm going to try to rewrite it as a difference of squares. What square to give me 16? What square to give me 49? 7, right? 4x plus 7, 4x minus 7. By knowing that quick shortcut to doing the differences of squares, a lot of what we need to be able to do in Algebra 2 is speed up what we already know in 2x, but 22x. I'm just going to kind of try to mix it all together as we go along. Y'all tell me what to do on this one. Huh? No greatest common 5, 22, and 48 don't have anything in common. So what's next? How many terms we got? 3. So that's going to be that X method thing. So we need to know what goes up top. So 5 times negative 48. 5 times 40 would be 200. 5 times 8 is 40, so that'd be 240. And it'd be negative because that's a negative 48. And then 22 goes in the bottom. So we need numbers that multiply to be negative 240 and add to be 22. So this is where, again, you got to know multiplication tables can help you out a lot. Since that 240 ends in a 0, I should be able to think about things that multiply to be 24 and put 0 on one of them. That'll help. This 240 has a lot of factors, but there are only 2 that we need. Multiply to be negative 240 and add to be 22. 30 times negative 8. Good job. Can I take my shortcut on this one? No. There's something else in front of x squared, so I can't do that. I've got to go through the steps. Instead of putting 22x, I'm going to put plus 30x minus 8x in the middle. Okay. All I'm doing is replacing that middle term with the 2 pieces I found for my x. Doesn't matter what order you put them in there. I put 30 first. You could have put the negative 8x first. It doesn't matter. Okay, it just changes the look of it. I put the 30 first because it was positive, and the 8 last because it was negative, because I was putting those negatives together. All right. Group the first two together. What's the GCF of 5x squared and 30x? 5x leaves x plus 6 in parentheses. What do I pull out of the second pair? -8. Remember, I'm always going to pull the same sign as that right there. If it's a minus, this is going to be a minus. If this is a plus right here, this is going to be a plus right here. Always. Okay, so if I pull the 8 out, that's going to give me x plus 6 again, which means I did it right. The matching parentheses, that's the key. So my factors, x plus 6, 5x minus 8. The matching parentheses, and then the stuff that's in front. It's our factored form out of that. Not too bad. Just take a little practice getting back on track with that. May have done it in quite a while. You don't do that very much in geometry at all. You know, there's not much factoring in geometry, unfortunately. Let's do this one. X squared minus 15x plus 26. Now we need a little bit more practice with those. So let's see if we can get there. Is there a GCF? No. 3 terms tells me to do that. What goes up top? 6. -15 goes on the bottom. What are our numbers? Yep, good job. Can I take a shortcut on this one? Yeah, I got nothing. There's a 1 in front of x squared, so that allows me to go straight to x minus 13, x minus 2. Take advantage of the shortcuts that happen. There aren't nearly enough of them to make your life that much better. So take advantage of the few that there are to speed you up some. Okay, so X method worked out great. Let's try that one. X squared minus 81. Difference of squares, I believe. What squared is 81? That makes it easy. X plus 9, x minus 9. Questions about factoring? Take some practice, get back on the horse with the factoring stuff. May have been a while. You may not have been great at it in Algebra 1. That's okay. We can get better at it right now. Okay. So you're just going to have to take the practice to do that. So